For this example, we'll calculate how far my calf will go before it reaches the ground. My calf will go around 1.8 meters, which may be a little bit tall for you, but here in the Netherlands, that's quite normal. The horizontal velocity that my calf will have is around 80 kilometers per hour. And we want to calculate how far it will reach. So therefore, we want to know delta x. We call the height delta y. And because we neglect the drag force, because that's way too difficult to calculate by hand, we calculate the only force that is applied to the calf that I have is the gravitational force. So therefore, delta y is equal to half g times t squared, where g is a gravitational acceleration. If we rearrange this equation, we will get t is equal to 2 times delta y times divided by g and the square root of that, which, if you fill in the numbers we have, we will get around 0.6 seconds. For the delta, now we want to calculate the horizontal distance, and therefore the time we have calculated, we multiply it with the velocity, and the velocity we call is the horizontal velocity is constant because we neglect drag force. So delta x is equal to the velocity times the time. Now, if we reach it in SI units, we will get meters is equal to meters per second times seconds. So therefore, indeed, we will get meters for our end result. So delta x is equal to the velocity we have initially, which is 80 kilometers per hour. But because it's kilometers per hour and we have here meters per second, we have to calculate it in a different way. So therefore, we do it times 1,000 meters per kilometer, because that's how much meters there are in a kilometer, divided by 60 times 60, which is the amount of seconds in a minute and the amount of minutes in an hour, times the time we have calculated here, so which is 0.6 seconds, which give us the which will give us the end result of around 13 meters, which is quite a lot. It's a very far distance. So if we think reasonably for 1 second, and we think of 30 meters, it's too far. So the conclusion we can have here is that the drag force is neglected, which is not what we want to do for a reasonable result. Here below, you can play with the sliders for the drag force and for the angle, which is this angle under which you calf to have a projection of how far the calf will go. Good luck.